Martian moon Phobos could tell us what Mars was like in the past. Mars has long been a point of fascination for scientists as they tried to uncover the planet's past and determine if it ever supported life. It turns out that Phobos, one of the Martian moons, may hold a treasure trove of information about what Mars was like in the past, according to new research. Mars has two small, funky-looking moons. The lumpy moons, Phobos and Deimos, were both discovered in 1877 and named after the sons of Ares from Greek mythology. Mars is named after the Roman god of war, which is Ares in Greek. Phobos means fear or panic and Deimos means dread. One NASA orbiter called MAVEN, short for Mars Atmosphere and Volatile Evolution, has been circling Mars for more than 6 years, collecting data about the planet to help scientists piece together how the planet lost its atmosphere and why its climate changed. Mars once had a thick atmosphere that allowed liquid water to exist on the planet's surface. Now, the Martian atmosphere is incredibly thin at just 1% the density of Earth's atmosphere. Phobos is such a close companion of Mars, about 60 times closer than the Moon orbiting Earth, that it has crossed with MAVEN's path multiple times a day during the orbiter's mission. While scientists don't know how Mars lost its atmosphere over time, they do know it escaped out into space, and Phobos is right in that escape path, said CNNT, lead study author and a researcher at the Space Sciences Laboratory at the University of California, Berkeley. Using data from MAVEN, Nennen and his colleagues took a closer look and determined that the orbit of Phobos passes right through a stream of ions-charged atoms and molecules that flow from Mars' atmosphere. These ions, which include nitrogen, argon, carbon and oxygen, have been escaping from Mars as it has shed its atmosphere over billions of years, and some of those may have essentially crashed into Phobos, the study published last week in the journal Nature Geoscience. Phobos is tidally locked with Mars, meaning that the same side of the Moon always faces Mars. This is similar to how our Moon always shows the same side to Earth. This means that one side of Phobos has been hit with a steady stream of particles from Mars, 20 to 100 times more than the far side of the Moon has received. Phobos has been patiently accumulating particles escaping the Martian atmosphere and may therefore have been holding for millennia a possible record of the lost atmosphere of the red planet, Nennen said. In other words, rocks and soil on the surface of Mars likely contain particles from the Martian atmosphere and could contain information about how that atmosphere evolved. A mission to Phobos. It's fortuitous that the Japan Aerospace Exploration Agency is sending a mission to Phobos in 2024 called the Martian Moon's Exploration Probe. The probe will collect the very first samples from the surface of Phobos and return them to Earth. Multiple missions orbiting in on the surface of Mars have helped scientists learn a tremendous amount about the red planet. The moons, however, are another story, and scientists aren't even sure where the moons came from. Researchers have 3 possible scenarios for these moons. It's possible that the moons formed at the same time as Mars, or maybe they were created after a large body impacted Mars. Given their appearance, they may even be asteroids captured by the planet's gravitational pull, Nennen said. I think the main reason why this enigma persists is because we do not really know the chemical composition of Phobos and Deimos from remote optical observations, he said. The best way to determine the composition of the Martian moons would be to analyze in laboratories rocks brought back to Earth. This is exactly what the Martian Moon's exploration mission aims to do. If the probe, also known as MMX, lands on the side of Phobos that faces Mars, the samples there may tell 2 different stories, one about Phobos and another about Mars. Nennen said that the Martian particles only reach the very surface of rocks on Phobos. A sample from the near side of the Moon facing Mars would therefore contain a unique record of the Martian atmosphere in its shallow layers, while showing the unaltered, primitive composition of Phobos in its inner core, he said. It's up to the MMX team how they want to use the information Nennen and his colleagues have gathered. To understand the origin of Phobos, we need to determine the primitive characteristics of its surface, CNNT said. We have created surface maps to show exactly where Martian atmospheric particles are being deposited on the surface of Phobos. The goals of MMX include revealing where Phobos came from and how it has evolved, as well as how it is linked with Mars. Previously, scientists have shown that material coming from the surface of Mars is also likely present on Phobos' surface. Due to large impacts on Mars which formed craters on the planet and liberated into space gigantic quantities of Martian surface material, which then showered onto Phobos, CNNT added. Studying a moon to learn more about the planet it orbits is something scientists have long applied to Earth's moon as well. After all, our own moon is hit with particles that stream away from Earth. Moons like ours and Phobos act like time capsules. They have no atmosphere or other elements that may erase the moon's record of its existence in the solar system. What we've seen in Apollo samples is that the moon has been patiently recording individual atoms coming from the sun and from Earth, said Andrew Papa, study co-author and associate research scientist at the Space Sciences Laboratory, in a statement. It's a really cool historical record. While Apollo astronauts were the ones to collect samples from the lunar surface to return to Earth, a rover about the size of a microwave will accompany the MMX spacecraft on the journey to Mars. The spacecraft will drop the rover on the surface of Phobos and it will explore the moon for about 100 days, capturing images and collecting samples that will later be returned to Earth.